In this video, we're going to see how easy it is to integrate an Amazon RDS SQL database with a .NET 6 web application. Hey everyone, Wes here with Productive Dev. I get a lot of questions about integrating SQL databases with .NET projects, and there are, of course, a lot of ways to go about this. Of course, there are many different SQL databases to choose from, whether that's Postgres or MariaDB or Microsoft SQL Server. There are lots of options, and there are also a few options for basically where we host those databases. So we could talk about spinning up databases locally. We could talk about spinning them up in Docker containers for dev purposes or for testing. Today, we're going to specifically look at setting up a SQL database in the cloud. And so for this, we're going to be using Amazon RDS. So we're going to do a deep dive into setting up a new database in RDS and looking at how we can integrate it into a new .NET 6 web API project. Now, if you've worked with .NET 6 in the past, I should say recently, maybe over the last 5 or 6 years, then you may be familiar with Entity Framework Core. And with Entity Framework Core, we have the ability to define our database schemas in a code-first fashion. So basically what we'll do is we'll define a number of different C# classes which basically define the entity models or the tables that will ultimately represent our data in a SQL database. So we'll look at using Entity Framework Core in conjunction with our RDS database, and we'll actually run migrations against that database. So if you've seen any of my previous videos as I'm building out .NET web applications, you know that I really enjoy using Postgres as a backing database. It is a fantastic open source SQL database. It's a very mature open source database system. So that's the one we'll be using here. Know that RDS, as we'll see, has several different options for us to choose from. So if you'd like to use Microsoft SQL Server or MariaDB, then we'll also look at how you can actually set that up very easily in RDS. So with that, let's go ahead and dive in and get started. If you get anything out of this video, I would really appreciate it if you like the video, and be sure to subscribe for more videos about working with .NET in the cloud, DevOps, and machine learning. I've got a lot of videos in the pipeline this year, and I really hope you enjoy the content. That said, thanks for watching, and let's go ahead and dive in. Okay, so let's take a look at the minimal .NET 6 web API that will be hooking up to a SQL database hosted in AWS using Amazon RDS. What we have here is an example of a .NET 6 minimal web API. So this is a new paradigm with .NET 6 that essentially allows us to create nearly a single file web API project. And if you've used other frameworks like Node.js, or if you've used Flask in Python, then this sort of may have a similar developer experience for you. It's basically a way for us to, again, use a single file, and we can do everything from create an instance of the application that will be running to setting up our dependency injection and configuration management, and then even mapping routes all within a single file. So it's pretty interesting. I haven't actually used it much before, and it is new with .NET 6, but I thought this would be a great example, or a great opportunity to see an example of it, since we're hooking up basically a very small API for the purposes of just demonstrating how we get this hooked up to RDS. All of the concepts regarding wiring up this API to a SQL database in RDS will still pertain to you even if you're not using the minimal API paradigm, but I thought I'd use it here as an example, as something that's new with .NET 6. So we have 3 routes here. We can see that our API is concerned with storing and reading and writing recipes. And so we have a new method on our instance of our web application here called map_get, and we can map GET requests and map POST requests to different endpoints. And so we can see here at the recipes endpoint, if we make a GET request, we're basically going to be reaching into our data access layer to get a flat list of recipes. Note that this will be incredibly inefficient if we have lots of recipes. This is going to do a full table scan and return all of the recipes as a single list. So again, just a simple example here. Typically this would be where we'd set up some pagination logic. We have another GET request endpoint where if we provide an ID as a leaf of this path, then we're going to get the recipe with the corresponding primary key back as a response. And then we have a post request for the recipes endpoint, which is going to allow us to pass a recipe object as JSON. And it's going to add this to our database layer and then call save changes. So this video isn't in particular going to go into much detail about Entity Framework Core other than to say that it is the ORM that we're using. What's happening here is essentially we're adding this object for tracking, and then we're sort of completing that transaction in the SQL layer by calling save changes async. So maybe in some cases we have some additional logic between the time we add an object for tracking and we actually want to commit that transaction. But that's why we have this sort of extra step here if you're unfamiliar with EF Core. Okay, so some very basic mapping of routes, and then in our configure services method, which we actually call before we map our routes, we can see we call that up here just after we create an instance of our web application builder. This is where we are, in this case, passing a service collection and a configuration manager, and we're basically calling services.addDbContext. So again, this is provided by Entity Framework Core, and it takes a type of DbContext which we've defined ourselves in this app.dbContext class. We'll take a look at that shortly. Basically, as a parameter, we have this action ops, and if we say ops.useNPGSQL, provided by the NPGSQL library that we looked at, or that we will look at, we can basically grab a connection string from one of our configuration files. And there are a number of different ways to provide configuration to a .NET Web API. Here we're using an appsettings.json file, which you can see here. We have a connection strings object which has a key appdb on it, or a property appdb, which for now is an empty string. When we actually create our SQL database in RDS, what we'll do is we'll get the connection string, or we'll build the connection string for it here and provide it in our configuration. Okay, if we take a look at the dependencies of this project, I'll select Manage NuGet Packages. You can see we have Entity Framework Core. We're using Entity Framework Core.design. This will be useful when we're running our database migrations, which is a way that we can actually basically apply the definition of our database and tables to a new schema in that SQL database. Then we have NPGSQL Entity Framework Core.Postgres. This again allows us to connect to Postgres databases using Entity Framework Core. Swashbuckle is used to set up Swagger, which is API documentation. We won't be looking at that in this video. And a configuration manager, which allows us to, or rather provides types that support using different configuration files. In our case, we're going to be using appsettings.json, and the only real magic that's happening here is we have an object with the name connection strings, such that when we use this useful extension method getConnectionString, the framework knows to look for that under this connection strings key. Okay, so that is a quick tour of the API itself. Here's the app.dbContext class. You can see that we're extending DbContext. We have a parameterless constructor here, and we have a constructor that takes the DbContext options of type app.dbContext, which again is our type here, and passes that to the base class DbContext. Then we have a virtual DB set of type recipe. So we'll take a look at that. This is our recipe, a simple plain old C# object with an ID that will serve as a primary key, and a title and some content for this recipe as string fields, or string properties rather. And yes, this is of a type DB set of type recipe. And so you can think of the DbContext as sort of an abstraction on the SQL database itself, and a DB set as an abstraction on a table. So this DB set provides us with a number of different methods for basically querying a table. And so we can query a table of recipes. Again, if we take a look back at our controller endpoints, then we can call things like toListAsync to get a flat list of those rows effectively in the recipes table, or to find a particular row by primary key, or to add a row to the database. So this DB set basically exposes a number of different methods that we can call to basically interact with that data in a SQL table. Okay, so everything is looking good here. Now we need to set up a database in RDS that we can connect to, and let's take a look at how to do that now. Okay, so here we are in the AWS console. We're going to look for RDS, which is Amazon's Managed Relational Database Service. And this is going to allow us to spin up a new database server of any number of different types of DBMS systems and essentially not worry so much about the underlying infrastructure. So it's just a fully managed database that we can spin up. We can do things like schedule backups and automatic updates, but basically all of the sort of underlying concerns, the lower level concerns of the infrastructure are managed for us, which can make things pretty convenient. So we're going to click Create Database, and you'll see here that we have a number of different options to select from. First of all, we're going to do a standard create process. This is going to give us more control over configuring what exactly it is that we're spinning up. And we're going to select Postgres. So you can see you have other options here as well: MySQL, Maria, Oracle, and SQL Server, as well as Amazon Aurora, which basically provides either a MySQL or Postgres compatible SQL database that has a lot of really nice scaling properties. In this case, we're going to look at Postgres in particular. And specifically, I'd like to spin up a Postgres 11.14 R1 instance. So with Postgres 11 here, you should have the option to select free tier. We're going to do this with a very small single database instance. So let's call this recipes demo. And we'll keep Postgres as the master username. And then you can either choose to auto-generate a password or provide a password. I'm going to create one here. And just be sure that if you do provide your own password that you remember what it is. We're going to use this in our connection string later. And we're going to select a T2 micro, which you can see is very small for a database server. We have one virtual CPU with 1 gig of RAM, and it's not EBS optimized, so not Elastic Block Store optimized. This is going to be essentially just a database that we would use in a very minimal development setup or testing setup. And so this wouldn't be something that we would consider production ready, but it will serve our purposes to sort of demonstrate how to hook up a database in general. We'll stick with standard GP2, general purpose SSD, and we can enable storage auto-scaling. Maybe this auto-scaling is something that we can talk about in a future video. There are some considerations here with regards to auto-scaling that can be pretty interesting depending on sort of use case for the database. We'll talk about that maybe in another video. We're going to turn on public access for now. And for VPC group, we just need to make sure that inbound traffic on the Postgres port, which is by default port 5432, accepts inbound traffic. I've created a security group for that. I can show you, we can just create a new one here as well. Let's call this Postgres users with no preference on the AZ. And we use password authentication. There's the ability to provide some additional configuration, including an initial database name and scheduling backups. We're just going to leave the defaults for this. And you should also see your estimated monthly costs here. Let's go ahead and create our database. This will take a few minutes, and you'll see shortly that we're brought over to our list of RDS databases, and you can see for the first few minutes the status is going to be in a creating state, and we will return here as soon as it's in a running state. Okay, so after just about 5 minutes, we now have a database with an available state. If we click on the database here, we will see that we have an endpoint for it now, which you'll see is a subdomain of rds.amazonaws.com. This is going to be important because it will be part of our connection string, as will the port and the username and password. So let's go ahead and grab this endpoint. We're going to copy it, and then we're going to head back into our code, and we're going to go into our app-settings.json file. So this connection string is going to be composed of a few different parts here. We're going to say host equals, and then that host that we just copied. semicolon, and then we're going to say port is 5432, which is the default Postgres port. Username is going to be Postgres, and then we'll have our password here. Now keep in mind that if this were a production database, or really even a test database, it's not really appropriate to store secrets in a configuration file. It's going to be checked into version control. So if that's the case, then I wouldn't check this into version control. There are other ways as well to use a parameter store to store secrets and to have them injected. In this case, just for the sake of simplicity, we're going to provide the full connection string in our appsettings.json file here, and so that's why I'm providing the password here. But just know that you shouldn't check credentials into version control for sure. So the password that I had here for mine was demodb. '080808 exclamation mark. And then as far as the database goes, we're going to provide this with, we can provide really any database name here. Let's call this app demo, for instance, and then be sure to end it with a semicolon. Okay, so assuming that your connection string is formatted properly, the next step is going to be running a migration, and I've already run a migration here, but I'll show you how to do that, and then essentially applying this migration to our database. And so for this, we're going to head over to the terminal. Okay, so here we are at the terminal, and currently my terminal is open at the root of a solution file which contains a subdirectory for our web project. Now I'll also note that, as is typical for videos that I make where I'm working on Windows, I'm using git bash as a terminal emulator, and so, or rather I'm using Windows terminal with git bash as the terminal emulator, and so this allows us to share Unix-like commands if you're running on Mac or another Unix-like environment. So what we need to do is actually to get into our web project, and what I mean by this is that you should have a terminal open at the same directory as your program.cs file that we looked at earlier. Now we also need to make sure that we have our EF Core tooling installed, and so for that we can run the command .NET tool install --global.NET EF. Now if this is already installed, you'll see a message like I see here. And if you didn't add the NuGet package for Microsoft Entity Framework Core Design earlier, we could also add that from the terminal using the command .NET add package. And then we just need to specify Microsoft.Entity Framework Core.Design. And you'll see if that's not added, it will be added to your project. You definitely want to make sure that your project is building, so you can run the command .NET build, and you should get a build succeeded. And then we want to create our first migration. Now you'll notice, and you may have noticed earlier, that I have a migrations directory, and I already have some files in here. These are auto-generated files that EF Core generates, and they're basically going to get run to do things like create tables and create columns and set the various constraints on those tables. And every migrations file has two methods, an up and a down, and basically we can sort of move forward and backward through these time-stamped migrations to basically deterministically recreate a schema as it was at a particular point in time. And so that's one of the sort of main benefits of this sort of migrations pattern. We can generate all of our entity models, the models that will be mapped to tables in our database using C#, and anytime we make changes to those models, as we say change or add properties, add or remove properties, change types, add new classes, then we're going to be running new migrations, and those migrations can then be sort of written in a deterministic fashion from any point in time for a particular database. So if we were starting with a fresh database, we'd start from the very first migration ever all the way up to, say the latest migration that was run. And so it's just a way for us to sort of track schema change over time and deterministically move either forward and backward in time through a series of migrations. And so I've already created one here, but I'll show you how to create your first one. We can do migrate .NET EF migrations, add, and we'll call this initial migration. Now, since I've already basically created one, this isn't going to do much for me here. That's okay. We're going to then basically update our database with this migration. So we can say .NET EF database update. Okay, so shortly, if we connect it to our database, we can see that it's running, and then we see done. So what this actually means is that the RDS instance that we connected to here now has a database with the name that we provided and the schema that's defined by our DbContext. So one way to sort of query this database is to use a GUI called pgAdmin. It's cross-platform, which is why I'm recommending it here. You may be familiar with command line tools like pSQL or other database management tools like DataGrip. There are many of them out there. pgAdmin is a really nice, easy to use, free resource that you can use to query Postgres databases. So I'll be using pgAdmin here for that. And what I'm going to do is I'm going to add a new server group. So let's go ahead and do that. So I'm going to right click on servers and I'm going to create a new server group. We're going to call this RDS databases. And under this server group, we're going to create a new server. So we're going to call this our recipes demo. And then under connection, we need to provide a host. And so we're going to come back and grab the endpoint from RDS. We'll paste that here. And then again, our username and password. And I'll save it and click save. So now we're actually going to be connected to our recipes demo database. So we'll expand this, we'll expand databases, we'll expand the app demo database, and we'll expand schemas and finally public tables. So once you kind of drill all the way down here, you can see we have a recipes table. And in fact, if we want to open a query tool, we can do that. So we'll right click and select query tool. And we can select star from recipes. And we'll go ahead and run this. Oops, and it is case sensitive. And with capital letters, we need to surround that with double quotes to preserve the casing. You can see we have a table with 3 columns, ID, title, and content, and the table itself is empty. So let's spin up our minimal web API and see if we can make a post request to add a new recipe to our RDS database. So I'm going to come back into Visual Studio. I'm just going to right click on the .NET RDS.web project, and then we're going to run debug. So we can do that here with debug. We can also just hit the play button. So we're going to hit the play button. It's the only project in our solution. So I have the project set up to actually open a new browser to visit the Swagger endpoint. We're going to disregard that for now because I haven't set up Swagger on this project, but you'll notice in the debug output, you should see URLs for where the application is listening. In my case, on HTTP localhost port 5290. So what we can do is I can actually open a browser with localhost 5290. So we'll do that. And if we hit /recipes, you can see that, well, nothing is actually happening yet because we don't have any recipes. So let's make a post request. For that, we can come to the terminal. So let's go ahead and make a curl request, and we can use curl to make a post request with $X and then post HTTP, and this is at localhost 5290/recipes. And then we can pass a header of type content type application/JSON, and then some data, which we can pass with -d here, and we can pass a JSON string, which in our case we can have a title, and let's just say bread, and then content. I won't write out an actual recipe here, but for our purposes, let's just say some good bread. Okay, so we're going to send this post request, and you can see as a response we get back an ID of 2 here in my case, with title bread and content some good bread. Okay, so if we take a look back at our API for one thing, and we refresh, making a GET request here, we now see our bread coming back. If we were to make a second post request here, and let's say soup. Okay, so we have another item added to our API, and if we go ahead and refresh that, then we can see we have another item coming back. And so this is all made possible because our post requests via our .NET API are writing to our RDS database. And so if we select start from recipes, we can see that we're actually updating our database, which is hosted in RDS, running Postgres, with the recipes that we're basically sending via these post requests. Okay, so that's about it for setting up RDS. I'm going to go ahead and basically tear down this server now. So we'll head back into AWS. I'm going to come back to the management console, and if we head back to our dashboard, we can view our DB instances, and if you select on the demo database that we created, and then under actions select delete, it's going to ask us to confirm by typing delete me here. And I would recommend, if you are using these databases for dev and you for any reason need to save a final snapshot, then you can select that here. You can also retain your automated backups. For now, I'm just going to disregard this and acknowledge that we can't sort of retrieve this again, and reconfirm with delete me, and then we'll go ahead and delete it. And so we'll see very shortly that this is now in a deleting state, and it will be removed shortly. So that's about it for this video. You can see it was relatively simple to get an instance of Postgres stood up in RDS and connected to our minimal .NET 6 web API. If you got anything out of this video, I'd really appreciate it if you liked and subscribed, and I'll catch you next time.